Hello everyone. This is a review of some of those limit questions from the review packet that you guys asked me to go over. So the questions that were asked were for 6, 8, 11, 15, 19, and 20. I apologize in advance if some of this is messy handwriting. My stylus has all of a sudden stopped working. Of course, perfect timing for that. So I'm just using my finger, so hopefully everything is clear and you're able to follow along. All right, so question number 6 was the first one. Now, this one is a little bit interesting. It goes back to the idea of L'Hopital's rule that we learned about. So we're given the information that f prime of x equals cosine of x and g prime of x equals 1 for all values of x. Now we're also told f of 0 equals g of 0 equals 0. But then we want to find this limit here. So if I'm asked to find this limit, technically what we're doing is we're finding the limit of the numerator and dividing it by the limit of the denominator. Now, as we all know, when we plug in 0 for both of those functions, up here they told us that f of 0 equals 0 and g of 0 equals 0. So if I evaluate both of these limits, this top limit is going to go to 0 and this bottom limit is going to go to 0, which we all know means that it's undefined, okay? But so now what we would normally do if we got 0 over 0 is we would try and factor out a common factor, cancel out a common factor, But we can't do that here since we're only given f of x and g of x. We're not actually given what the function value is. So this is where we're going to use L'Hopital's rule. And as a reminder, L'Hopital's rule says that if you were to get 0 over 0 when you first plug into a limit, what you're going to do is you're going to take the derivative of the numerator and the derivative of the denominator and then replug in. So what we're actually able to do is say, all right, now I have the limit as x approaches 0 of f prime of x divided by the limit as x approaches 0 of g prime of x. So we're just evaluating now the derivative of both the numerator and denominator. Well, what do you know? That's the information that we were given at the beginning of the problem. So if I were to plug in 0 to f prime of x, I'm not plugging in 0 yet, but f prime of x is cosine of 0, and g prime of x is 1. So if I evaluate the limit as x approaches 0, that means this is going to be cosine of 0 that I have to evaluate divided by 1. Now I'm going to erase a little bit of what's up here to give myself a little bit extra room. Cosine of 0, we're going to go back to our unit circle. And at 0 degrees, that coordinate is 1, 0. We all know that the coordinates on the unit circle are cosine, sine. So cosine of 0 is the x value at 0 degrees, which is 1 for our numerator, divided by the 1 that was in our denominator. So overall, my answer is 1, which was choice B on that packet. All right, so again, because of the fact that we got 0 over 0 from the initial limit, we are able to apply L'Hopital's rule where we take the derivative of both the numerator and denominator, and then we can evaluate the limit over again. All right, hopefully that was able to clear some things up with that. All right, moving on to question number 8. Question number 8 is asking, based on that graph, which of the following statements is false? Which is false? Well, right here looking at choice 1. Choice 1 is saying f is continuous at a. I don't know about you, but I don't see a continuous function right there. All right, I see a point discontinuity, a removable discontinuity. If there is a hole in that graph, all right, we have a lovely hole in that graph at x equals a, meaning it is not continuous at a. So automatically right there, choice A is our false option. Okay, but let's just kind of go through the other options as well. It says B says f has a relative max at A. Well, in order to have a relative max, you need to go from a positive slope to a negative slope. That's not what's happening in the graph. That graph is continually increasing. So since we don't have that change in slope, we can't have a relative max. Part C, x equals A is in the domain. Well, the domain is any of the x values that have a point plotted on it. Even though it's not continuous at A, there's still a point plotted at A right up here. And so that point is part of the domain, absolutely. Now, D and E go back to the idea of limits, okay? D says the left-hand limit is equal to the right-hand limit. Well, absolutely. As I approach A from the left and as I approach A from the right, we are approaching the same y value. So that means the left-hand limit equals the right-hand limit. And because of D, that actually is exactly why E is correct. These two answer choices pretty much have to go hand in hand. If the left-hand limit equals the right-hand limit, then automatically the overall limit exists. All right, hopefully that cleared up that one. Next question is number 11. Number 11, a little bit different, a little bit maybe more difficult, but definitely based on process of elimination, we should be able to get the correct answer here. Again, it's asking for which of the following statements is false. Well, let's go through our options. A says f of A exists. That just means, is there a point plotted at A? Well, there is a point plotted at A, so that is a true statement. All right, f of A exists. There's a point plotted right there. So that is a true statement, not our answer. B, f of x is defined for 0 is less than x is less than A. Well, that's true. Look at this side right here. Everything less than your A value, it actually only starts at 0, so I was wrong there. From 0, that's a red color, between 0 and A, all of my x values are defined. That's absolutely true. Notice how this is a just less than statement, which means it does not include A, which is important. All right, if that said less than or equal to, then you'd also have to include A there, which may change your answer. All right, well, this, again, as we just said, is a true statement, so that's not my answer. Part C, the function is not continuous at x equals A. Well, absolutely, because, again, we have a hole at A. We have a point discontinuity. So that right there is a true statement, so that's not our answer. D, the limit exists for f of x. Well, again, you're asking yourself, does the left-hand limit equal the right-hand limit? And if we look at that at x equals A, as I approach A from the left and as I approach A from the right, we're approaching the same y value. So therefore, this is a true statement, which is not our answer. So that just leaves us with choice E, which is our correct answer. But if we want to know a little bit more in depth why that is our answer, that goes back to our idea of we are now talking about the limit for the derivative. So if we were to plot the slopes of this function, right, I would kind of estimate that to the left of A, I don't know, I could, make an argument that maybe the slope on that line, it's a linear line, so the slope stays the same. That slope is maybe 1 or 2. So I'm just going to go with 1. So pretty much everything to the left of A has a slope of 1. And then everything to the right of A, I'm going to guess has a slope of maybe like -1. So everything to the left of A has a slope of -1. So I just made a graph for f prime of x, and the question is asking, well, does the limit exist for f prime of x at A? Well, no, it doesn't, because we have this jump discontinuity in our f prime function. And anytime we have a jump discontinuity, the limit doesn't exist. So that explains why E is our correct answer for question number 11. Okay, moving on to question 15. Question 15 is probably the one that I would say 15 and 19 were the ones that I would say would be the most difficult for this problem. This is an interesting type question, and the reason is because of the setup of this limit makes it confusing for how you're actually supposed to evaluate it. So what you're actually doing here, which seems like it doesn't really make sense, but this limit is actually kind of equivalent to saying that you're going to take the sign of the result of the limit as x approaches 1 of f of x. That's really what you're doing here. And I know it doesn't really seem that way from the question that we were given, but the first thing that you're going to do is find this limit as x approaches 1 of f of x, and then you're going to evaluate sine of that value. So if I look to my f of x graph that we were given, and I want to find the limit as x approaches 1, well, as I approach 1 from the left and as I approach 1 from the right, it's both approaching the same value, and that y value is 2. So this whole limit goes to 2. So that means I'm going to evaluate the sine of 2. Now, as you can see from the answer choices, that they're all decimal values, that lends to the fact that this is a calculator question. So you are simply going to plug sine of 2 into your calculator. Make sure your calculator is in a radian measure. And what you should get out is 0.909, which is choice A. Okay, so again, from the initial problem, it doesn't seem like this is the setup that we would be using, but that is pretty much how you would deal with that problem. You deal with the limit of the f of x value first, and then you go back and plug that into the sine function. Okay, moving on. Question number 19. Now, 19 is one that a lot of the comments that people had was, why can't it be choice B? Well, I completely understand your question. When I initially looked at this question first, I also chose answer B. However, thinking upon it more fully, all right, anytime you are told that you are dealing with an asymptote, so more specifically just this word, the AP lends an asymptote to the idea of end behavior. And so this is really an end behavior question. So you are looking for the answer choice that relates to the end behavior of the graph, which is right here, choice E, because you're looking at a limit as x approaches infinity. And when x approaches infinity, that is also referring to the end behavior of the graph. Now again, why not choice B? Because it does really seem like it would make sense. If 2 is an asymptote, you can't equal 2 for all of x is greater than or equal to 0. I get it. I'd want to say that answer too. However, even though all us math teachers, whenever we're talking about asymptotes, we always say the function can never touch or cross over an asymptote. There are a few minor exceptions to that rule where part of a function, namely if you have a piecewise function, okay, if you have a piecewise function, there are a few times where part of the graph could actually cross over an asymptote. We don't deal with those. We haven't dealt with those yet. Those usually come up in higher math level classes. But so this becomes not officially true because of those minor exceptions sometimes. All right, so this can no longer be an answer choice. But again, the main thing here is anytime you see the word asymptote, we are looking to deal with an end behavior type question. And the only answer choice that deals with end behavior is choice E when the limit is approaching infinity. All right, that means that you're going to the right forever, and that is your right hand end behavior. Okay, hopefully that was able to clear that up a little bit. And finally, question 20, we were given 3 graphs. It says, which of the following does the limit as x approaches 4 for f of x exist? Well, again, just make sure that you're not thinking that these are f prime graphs. I know we've dealt a lot with looking at the graph of f prime, but these were all the graph of f. So you're literally just looking, do I have a jump discontinuity? If I have a jump discontinuity, like in choice 3, this limit automatically does not exist because the two levels, as I approach from the left and as I approach from the right, we're ending up with two different y values. Okay? But even if I have a hole, even if I have a point discontinuity, as in 2 and choice 1, if I were to evaluate at 4, both of these are at 4, okay? If I was to evaluate at 4, even though there's that hole there, the left side and the right side are both approaching the same y value, which in my opinion looks like it's about 4 in this graph and about 3, that's a little high, about 3 in this graph, wherever that open circle was. And so therefore the limit does exist in graph 1 and graph 2 because the fact that the right-hand limit equals the left-hand limit for both of those graphs at x equals 4. Okay? I'm hoping that cleared those questions up for you guys. And if you have any other questions, feel free to let me know. All right? Hope you guys are all doing well. And we'll talk again soon. Bye.